Good evening, students. Today we are going to discuss the further topic of linear differential equation of homogeneous form. In this equations, constant coefficients में, first of all, we have already learnt about in my previous lecture that we have to find the complementary function by assuming that f dy is equals to 0. As I solve it, I find the complementary function cf for this by making the c1 e to the power ax or all these. The step number 2, for this function qx, we have to find another solution that is known as particular integral for the equation with the qx. Both the solution, complementary function and particular integral, the required solution for the given equation will be cf plus pi, yani complementary function plus particular integral. The main thing is that how to find this particular integral, how to find this pi. There are 5 different ways to find the pi for the different cases also. So we will discuss these all 5 cases one by one. Let us start now. Now for finding the particular integral, we have to evaluate 1 upon fd of qx. This qx can be 5 different ways. The case number 1 is when function qx is in the form of e to the power ax, then particular integral will be 1 upon f of d e to the power ax will equals to 1 upon f of a e to the power ax. Means just put the coefficient of x in the function in place of d. But there is a case when f of a should not be equals to 0. This is the important part. This f h can never be equals to 0. If f of a is equals to 0, then there is a important formula for finding that. You should always learn this formula is 1 upon d minus a to the power r of e to the power ax will always equals to x to the power r upon r factorial e to the power ax. This is a very useful formula. You should remember it always. This will be applied when f of a is equals to 0. Then we will use it in different way. Let us do some example first of all for this, then we will go ahead. So here is the first example for finding the particular integral as well as solve the differential equation. As we know, for solving this differential equation, there is a function of x. So we will have to find the complementary function as well as particular integral. So first of all, for complementary function, the auxiliary equation is m square minus 3m plus 2 is equals to 0. So that I can say m minus 2, m minus 1 is equals to 0. So m is equals to 2 and 1. Therefore, the complementary function cf is y is equals to e to the c1 e to the power 2x plus c2 e to the power x. Now for the pi, means particular function, we have 1 upon d square minus 3d plus 2 e to the power 3x. By applying this formula, we just replace d as a, means coefficient of x, this is 3. So I can say it will become 3 square minus 3 into 3 plus of 2 e to the power ax. It is 1 by 2 e to the power 3x, This is our particular integral. Therefore, the solution of equation is y is equals to cf plus pi. It means y is equals to c1 e to the power 2h plus c2 e to the power h plus 1 by 2 e to the power 3h. This is our required solution for the given equation. Now there is another question. It is a very important question. Be careful by doing this. First of all, for auxiliary equation is 4m square minus 1 is equals to 0, or I can say m square is equals to 1 by 4, or m is equals to 1 by 2 and minus 1 by 2. So the complementary function y will equals to c1 e to the power x by 2 plus c2 e to the power minus x by 2. This is very easier way. Now see carefully the particular integral. In the case of particular equation, the equation will become 1 upon 4d square minus 1 e to the power x by 2. When I applied the coefficient of x in the d, I will get 0. Here f of a is equals to 0, means I can't apply directly the value of d as 1 by 2. So I will factorize it. For this I will get, it will become 1 by 4 d square minus 1 by 4 e to the power x by 2, or it will be 1 by 4, this is 1 upon d minus 1 by 2 d plus 1 by 2 e to the power x by 2. I just factorized it by a square minus b square. Now if I applied 1 by 2 here, it will become 0. So I will not apply it here. First of all I applied here only. Then I will get 1 by 4 1 upon d minus 1 by 2 into 1 by 2 plus 1 by 2 e to the power x by 2. It will become 1. Now the equation just reduce as 1 upon d minus 1 by 2 e to the power x by 2. Now as I write in the previous the important formula, that is 1 upon d minus a to the power r is equals to x to the power r upon r factorial e to the power ax. Apply this rule here. So I will get, it will be 1 by 4 x to the power r. R means the power of this is 1. So it is x upon 1 factorial e to the power x by 2, or I can say it is nothing just x by 4 e to the power x by 2. Therefore, the complete solution of given equation is y is equals to cf plus pi, or I can say y is equals to c1 e to the power x by 2 plus c2 e to the power minus x by 2 plus the particular integral, that is x by 4 e to the power x by 2. This is our required solution of the given differential equation. Now there is a case number 2. If the qx is the function of sine or cos, then what will happen? Then the solution, the particular integral for the equation is 1 upon of f of d square. I have here, be careful about that, that is d square of sine ax or cos ax, whatever it is, it will equals to 1 upon f of minus a square, whatever it is, sine ax or cos ax. Remember this one. I don't write this square as out of the bracket. It is just on a A, not minus. This minus sign will always there when we put sin AX or cos AX. Just we will do an example, we will find the solution. Let us do a simple example. For doing the example, I would like to write some basic formulas. We have already learnt about them. That is, we know that, here I wrote useful formula. We know that sin AX is always equals to e to the power a iota x minus e to the power minus a iota x upon 2 iota, 2a iota I think, yeah. And the cross ax is e to the power a iota x plus e to the power minus a iota x upon 2. These two formulas are very useful in these questions when qx is the sign of cross or function. Let us see how we can solve it. Just state an example. Now there is an example for the case number 2. Equation, first of all we will find the auxiliary equation. So that the auxiliary equation is m square minus m minus 2 is equals to 0. By factorizing I will get m minus 2 m plus 1 is equals to 0. I can say m is equals to 2 and minus 1. Therefore the complementary function is y is equals to c1 e to the power 2x plus c2 e to the power minus x. Now for the particular integral, the function will become 1 upon f of d sine of 2x, or it is 1 upon d square minus d minus 2 sine of 2x. As I told you, the formula for that is 1 upon d square of sine ax is equals to 1 upon f of minus a square sine of ax. Means wherever there is a d square, means even power of d, put the value of coefficient of x in that with the negative sign. So I can say it can be written as 1 upon minus 2 square minus d minus 2 sine of a 2x. Here I can see here a is 2, so I put in d square only, minus sign with outside. So it will become 1 upon minus d minus 6 sine of 2x. Now just minus take it out, and that is 1 upon d plus 6. Just rationalize it, d minus 6 of sine 2x, that is become 1 upon, that is d minus 6 upon d square minus 36. The minus sign is out already. It is sine 2x. Apply again for d square minus 2, I will get minus d minus 6 upon, that is minus 4 minus 36 sine of 2x. It will become 1 upon 40 d minus 6 sine 2x. Now d for derivative, d by dx. So when we multiply this one, I will get 1 upon 40 derivative of sine 2x minus 6 sine 2x. It will become 1 upon 40 derivative of sine 2x will be two cos 2x minus 6 sine 2x. So you know how to write. Now the solution is Therefore, the particular interval is this. So we can say therefore solution of equation is y is equals to CF plus PI. This is our PI and this is our CF. Just put these two values and add them, you will get the answer. Now see this question, it is another very important question for the exam point of view. First of all, auxiliary equation, that is m square minus 4 is equals to 0, or I can say m is equals to plus minus 2. So the complementary function y is equals to e to the power c1 e to the power 2x plus c2 e to the power minus 2x. This is the simplest part of this solution. Now this is here for pi, here we can say qx is equals to cross square x. I have the formula for cross ax, not cross square ax. So I will have to change it by taking as it is nothing just 1 plus cross 2x by 2. You know cross square x is equals to 1 plus cross x 2x by 2. So the pi will be 1 upon d square minus 4 1 plus cross x by 2. As 1 by 2 we are taken out, so it is 1 upon d square minus 4 of 1 plus 1 upon d square minus 4 of cross x. I can write as 1 upon 2 1 upon d square minus 4 e to the power 0x. We know that 1 can be written as e to the power x. Again plus 1 upon d square minus 4 of cos x. Now by the exponential rule, case number 1, when you apply d is equals to 0, it will become 1 upon 2 minus 1 by 4 only, and here it will become 1 upon minus 1 square minus 4 cos x. So it is nothing just minus 1 by 8 minus, that will be 5 to the 10. This is cos 2x, sorry for that. If there is 2x, then it will become minus 2 square. It will become minus 6, minus 8 into 2 plus minus 1 by 16 cos of 2x. I just write as an h, sorry for that. That is cos 2x. This is our pi. So the complete solution y is equals to CF plus pi, or I can say y is equals to C1 e to the power 2x plus C2 e to the power minus 2x plus, here I can write minus 1 by 8 outside, so minus 1 by 8 1 plus 1 by 2 cos 2x is the required solution of the given differential equation.